Hello and welcome to Rectangular Approximations. This is something that's very exciting in calculus that calculus students really want to figure out. We've got this curve. I did the same curve twice, and we want to figure out what is the area of that pink thingy. Now, there's two ways that we could do that. We could make a lower sum and we can make an upper sum. So we can make a bad guess at how big this space is. So I could make these thingies that are bad. So I'm only going to count boxes that are below the thing. Alternatively, we could also make a set of boxes and we can kind of square this thing off with boxes that go above our curve in order to try to figure out what the area of that thing is. Because all I really know, I don't know how big this area right there is. I can't figure that out. But I know how big this square is. It's 1 by 1. And then we got another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the lower sum is about 10 units squared. Okay. The bigger sum is we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that would be 16. So this would be an upper sum. So we know that the actual area, oop, the actual area's got to be somewhere in the middle. It's got to be somewhere in between those two. Because if we look at the blue one, there's a bunch of ones that we're wasting. We're not counting this stuff. We're not counting this stuff. We're not counting this stuff. So we're definitely under with that blue guess. With the red guess, we're over because we're counting this stuff over here and that little bit and that little bit. So we're probably better with the red one. So it seems to be going a little bit more towards the red one. Um, but the red one is definitely an overestimate for where the area of that pink region could be. Yeah. In this one, we are actually given the equation of that curve, and we're again trying to figure out what is the area inside of this space. And we don't have a good way of doing that. So we're just going to kind of guess with rectangles. So we've got different sets of rectangles. We'll do the lower one first. So we're just going to do the rectangles that are below the line. So this would be a lower sum. To find the lower sum, we would need to figure out what the area of all of those rectangles are. Okay, well, each rectangle is 1/2 wide. So we've got a 1/2 times its height plus another 1/2 times another height plus another 1/2 times a third height plus another 1/2 times our last height. But all of them are 1/2 wide. So we could write all those 1/2s, or we could just do 1/2 times all the heights. And then it would be a lot easier to figure out. Okay, well, how tall is this line? Well, I don't know how tall that is, but I do know how tall this is because it's right on our curve. And it's right on the curve when the x value is 1/2. So that is 4e to the negative 1/2 for that first one. Then we've got this one right here, dot. So that one's also on that curve. We don't really care about the other orange part because that we don't know how tall that is, but we do know where that pink point is because it's when the x value is 1 and when the y values could be wherever we plug in. So that's going to be 4e to the negative 1. plus, we got a little blue bit right here, dot. That is 4e to the negative 3 halves. I was hoping I'd be able to fit all these in there, but I'm not gonna. 4 to the negative 3 halves. Plus our final one, which is right here, that is 4e to the negative 2. So if we calculate all that together, we should be able to figure out what the area is of all of those lower rectangles. And that's a matter of just like typing that into your calculator. Those are all e's to the negative, like it's 4 divided by e, but that's not nice. And 4e to the negative 1/2, that's not nice. So it's just a matter of just typing all that into your calculator. I don't think that's worth our time in this video. So I will just tell you, after typing in that all into the calculator, I got 2.666. So we know that the actual area underneath that curve, we can erase all this garbage, the actual area inside of there, can I color it, please? The actual area inside of here should be bigger than 2.66 because we were pretty low. We didn't take into account that space, that space, or that space, that space. So we're underestimating that area. We can do an upper one. As well. So we just did a lower. So to do the upper sum, we need all of the ones that are tall. So whoop, 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 and whoop. Okay. So we still have that same width of 1/2. And then we've got all of our pieces. And we just want the pieces, the parts of those triangles that are touching the curve. So the first one is at 4 and then e to the 0. Oh, cool. That's just a 4 because e to the 0 is 1. Nice. Plus whatever this point is. So that is going to be 4. Wait a minute. We did that one before. It's this one. 4e to the negative 1/2. Interesting. The next one, hey, we did that one before. That was 1. So this is plus 4e to the negative 1. Interesting. Okay. And then the final one, that we did that one as well. Well, it was blue, but oh well, we just got another blue. So plus 4e to the negative 3 halves. Interesting. So it's basically the same thing, but we're just swapping this 4e to the negative 2, which is a regular 4. All right. Well, we typed that into our calculator. Again, not really worth our time. This turns out to be approximately 4.395 when you type that into your calculator. Well, neat. So we know that the actual area underneath that curve is somewhere between 2.66 and 4.395.